Okay, so the next question that we got on the menu today is what are the basic differentiation formulas? Okay, now it's kind of a vague question, but here are the main derivatives or the derivative systems that you kind of need to know. Okay, so the derivative of a constant is just going to be, so d over dx of a constant, let's call it c, is going to be 0. Okay, and that's always true. For polynomials, or for powers of x, or x is x with power, is d over dx of, let's say, x to the power of n. N could be any number. If it's 0, well, it's just going to be a constant, and that will be a constant situation if n is like that. It's going to be like this. So it's just going to be n multiplied by x to the power of n minus 1. It really is that simple. Okay, the next thing that we want to do is logarithms. So the derivative, d over dx of log with base b of x is equal to 1 over natural logarithm of the base times x. And for ln of x, base is e equals 2.718 on and on and on. So if it's a natural logarithm, of course it would be the same formula, except that ln of the base, that would just be a 1. So I guess you wouldn't need to necessarily write that. Okay, and exponents. So the derivative of d over dx of some base to the power of x is going to be the natural logarithm of the base multiplied by the base of the thing to the power of itself. Okay, and of course if the base is e, like 2.718, the ln of the base is just going to be a 1 term, and that can be ignored. Okay, so these are the basic. And other ones are, the main ones are for trigonometry. Look like this. So d over dx of sine of x, that's cos. And d over dx of cos of x, it is negative sine of x. If you forget the negative, you're going to be in trouble. And for tan of x, I guess just to be complete, even though tan of x is really just sine x divided by cos x, equals to secant squared of x, which is equal to 1 over cos squared of x. Okay. The rest of your trigonometry stuff can be made with respect to sine and cos. But some other things that we need to talk about is, let's say we have functions multiplied together. So then we have product rule. So if we want the derivative, d over dx of f of x multiplied by g of x, we're going to want to do, well, the derivative of f of x multiplied by the natural g of x plus the natural f of x multiplied by the derivative of g of x. Okay, and there's a similar rule that's not exactly the same for division. So suppose we have the quotient rule. Here we got d over dx of some function f over some function g of x. And this would be f prime, so the derivative of x multiplied by the natural g of x, minus, don't forget the minus, f but natural, multiplied by the derivative of g of x, all divided by natural g of x squared. Okay? And the last rule, that possibly is the most important rule, is the chain rule. Put a star because it's so important. The chain rule is you use it when you have one function that takes another function as the parameter. What I mean by that is, like, instead of just f of x, the argument to f of x is another function g of x. Okay, so the chain rule for this in action is going to be you have to multiply it by the derivative of the internal multiplied by, how did they list it here? Yeah, I don't think they did, and it's the most important one. I'm going to just verify the formula just so I know for a fact that I can't get it wrong. Okay. So you're going to keep your f derivative. Well, you're going to take the derivative of x, but the inside of x is going to be the same. And then you just got to multiply the whole thing by the internal derivative g of x, the derivative of that. Okay, so these are the basic differentiation formulas. It's not that many to remember. And if you know these, well, all the derivatives will assemble themselves. Okay, cool. So, the above solution could have the chain rule and derivatives of logs, exponents, trigonometry, and trigonometry. Cool. Okay.